Hello and welcome to this video on using the information your hydrometer gives. A previous video looked at the form and function of hydrometers. This briefly touched on the implications of the readings taken and what they are used for, but this video will go into detail. The synopsis of that video is that you take a before and after measurement of the density of your brew. This change tells you how much sugar is converted into alcohol, how much alcohol is present, and more based on the hydrometer used. This video will focus on sacchrometer readings as they are most commonly used and most flexible. Let's start with a more detailed description of density as it is used in this context. Everything has mass. In a fluid like water, solids may dissolve, but they still have mass that is spread across the volume of the fluid. This mass exerts force, and this force is the specific gravity of the solution that you measure with a hydrometer. You can measure this specific gravity by applying a known quantity of competing pressure. The hydrometer does just this. It has a set mass that goes into the fluid and displaces it. This makes the fluid, such as water, push back. Any solids dissolved in the fluid will also apply their own pressure. This combined force will compete with the hydrometer until it reaches a balance or equilibrium. For the purposes of this video, and to keep everyone from becoming math crazed, we can assume the specific gravity equations have been done. If you want details on this process, there is a link in the description box below. The hydrometer is designed such that it has the majority of its mass at the bottom, but the volume for it is large, which creates buoyancy. Without buoyancy, the hydrometer would be a rock for all intents and purposes. Hydrometers gain mass compared to the environment when you ferment, as it is calibrated to either a set amount of sugar in solution, to alcohol, or water. This density shifts during fermentation, so the solution is less dense. Less dense means less force, pushing the hydrometer up. This leads to it slightly falling deeper, as the suspending forces are lost. This is where the change comes from, and what you are measuring. Now, if you have done everything correctly by measuring the before and after density with your hydrometer, you can confirm fermentation occurred. You will also have a measurement called final gravity. The first measurement, or original gravity, is also needed as most reference charts use the difference. To do this, you find a percentage alcohol chart. Some examples are linked below, and most good brewing books include at least one as an example. It is good to either use a digital version or photocopy yours for this exercise. You take the original gravity measurement on the side of the table and trace this row across. Highlighters work well for this purpose. Now go to the top or bottom of your table and find your final gravity measurement. Trace this column and it will eventually intersect with your original gravity row. This is your alcohol percentage. Some tables will give you further information. Some good examples are attenuation, but the one of most interest here is how much sugar to add per liter to get a certain alcohol percentage. This works in a reverse way to the normal approach. You take your desired crossover point, or alcohol percentage. You ignore the final reading for now, and instead go horizontally to find the grams per liter number. You prepare your fermentation to match, and then see if your yeast could ferment enough sugar out at the end, using your final gravity. As a further step in brewing, you can calculate the alcohol content for yourself. This can be reversed to calculate the needed original gravity for a higher alcohol percentage. This uses the two measurements discussed so far, original and final gravity. You take your readings and remove the decimal point to simplify the equation, and subtract your original gravity from final gravity. This is multiplied by the density of alcohol, which is a factor of 7.46. If you carbonate or use a secondary fermentation, you need to increase this by 0.5 to 7.96 due to the additional sugar and consequential ethanol. Some sources suggest you adjust for this regardless of whether you bottle or otherwise condition your brew. The other common option is to use original gravity less final gravity multiplied by 131.25. This gives a good but not entirely accurate measure of alcohol content. One reason for this is that many brewers choose to simplify the formula and round 131.25 to just 131. This makes it much more simple and possible for people to calculate with pen and paper. You can simplify the equation quite a bit, but in doing so you lose accuracy, especially with high concentrations of alcohol. There are calculations that exist to be more accurate and reliable. To use them, you need to be inclined toward math, and a link to the full explanation of this process is in the description below. Just remember to use BODMAS when you try to calculate this, or your calculation will fail. You take two measurements that will be new, original extract and remaining extract, which are calculated from the two known gravity measurements. You subtract the original extract from the remaining extract. This is divided by 2.066, less your original extract multiplied by 0.01067. The accuracy between the three options becomes apparent as the difference between the original and final gravity measurements get wider. The wider the difference, the less reliable the first two calculations are. You can view these three formulas as a form of both refinement and variation which is developed over time. With all of this in mind, you can save yourself a lot of hassle by simply using the brewing software that is available, an online calculator, or a brewer's reference table. Thank you for watching this video. If you have found it useful, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions below.